Thanks so much for joining us for tonight's event. My name is Kevin. I'm one of the event hosts here at Powell's Books. And before we begin, I want to encourage you to check out our lineup of upcoming virtual events by visiting our website at powells.com. If you don't already do so, please follow us on our social medias, Twitter, Facebook, Instagram, as well as our YouTube channel. Tonight, we're excited to welcome Emily Levesque in conversation with Jonathan McDowell. From a childhood reading of A Wrinkle in Time to discovering a new species of star, award-winning astronomer Emily Levesque has spent her life exploring the universe, and now she wants to share that exploration with the world. Humans from the earliest civilizations through today have craned their necks each night, using the stars to orient themselves in this large, strange world around them. Stargazing is a pursuit that continues to fascinate us. From Copernicus to Carl Sagan, astronomers throughout history have spent their lives trying to answer the biggest questions in the universe. In her book, The Last Stargazers, Emily shares the stories of modern-day stargazers, the people willing to adventure across high mountaintops and to some of the most remote corners of the planet, all in the name of science. From the lonely quiet of midnight stargazing to tall tales of wild bears loose in the observatory, The Last Stargazers is a love letter to astronomy and an affirmation of the crucial role that humans can and must play in the future of scientific discovery. Levesque shows how astronomers in this scrappy and evolving field are going beyond the machines to infuse creativity and passion into the stars and space, and inspire us all to peer skyward in pursuit of the universe's secrets. Emily is joining us tonight from Seattle. Levesque will be joined in conversation by Jonathan McDowell, astrophysicist at the Harvard-Smithsonian Center for Astrophysics. McDowell is the creator and editor of Jonathan's Space Report. That's an email-distributed newsletter documenting satellite launches. He's joining us from Somerville, Massachusetts. This evening's event will also include a Q&A. Please use the Q&A button that's at the bottom of your screen if you'd like to ask a question at any time. And if someone has typed a question that you'd like to know the answer to, you can even upvote that particular question. Perhaps most importantly, please support Emily and Powell's by purchasing a copy of The Last Stargazers from us. A link to buy that book will be shared in the chat a couple of times this evening. Emily, Jonathan, thanks so much for being here.
Thank you.
Thanks so much for inviting us.
So, good evening, Emily. It's really nice to see you again. We've been separated by COVID for some time, and I have to say, I love your book. It's really, I think, a fresh take, and we have I find that I wanted to start off by asking you. I find that a lot of people, even who are like really into astronomy, don't have a very clear idea of what the life of an astronomer is like. And that's what your book does so beautifully, is introduce people to what a early 21st century astronomer does. And so maybe you can tell a little bit about that, how you feel that differs from like people's perceptions as you've talked with them about what an astronomer is versus what an astronomer really is.
Yeah, that idea of showing people sort of a behind the scenes glimpse at the world of professional astronomy is what propelled me to write the book. And it came in part from the questions that I would get asked by people. I would sit next to somebody on the plane and tell them I was an astronomer, and they would ask, oh, do you own your own telescope? And do you just do your work from your backyard? I'd then explain that I live in Seattle, and they'd kind of get this look, really? Or they would ask me if I got to travel to the Hubble Space Telescope, which is in space. Or they would be amazed that I was awake. They would be convinced that I had to be nocturnal to do the job. And they're all really fair questions, because I think for almost everyone I was talking to, they'd never met an astronomer before. There's about 7.5 billion of us on the planet, and about 50,000 professional astronomers. So it's a pretty rare field. And alongside that, we have heaps of folks who may not be professional astronomers, but who love space. They love, the beautiful Hubble photos like what we see behind you. They love the romance of, we took a picture of a black hole, or there's an asteroid passing close to Earth, but they don't think about what professional astronomers, the people who are taking those photos or studying those asteroids, actually do. I wrote this book in part by interviewing more than 100 of my colleagues, and mostly just prompting them to tell me stories of what it was like for them to be astronomers and stories of working at telescopes. But there were a few questions I asked everyone, and one consistent question was, what's the biggest mismatch between what people think astronomers do and what we actually do? And a lot of people would say, we don't look through eyepieces anymore, which sometimes makes people sad. But some of the biggest telescopes on the planet, we have not even made eyepieces for. We observe by sending whatever the telescope is pointed at to an enormous digital camera or a really sophisticated instrument. And then they also answered, this job is a little bit more adventurous than you might think. You might imagine astronomers just patiently sitting inside a telescope night after night, waiting for the sky to do something. And we're traveling all over the planet to really remote telescopes. We're frantically working through one night of access at a telescope where we want to point at galaxies halfway across the universe. And the pace and excitement of it, I think, surprised some people. So those were the key things that I wanted to get across in the book.
Yeah, I think that the pressure and the pace can be something surprising to all of us. And I remember one night when I was on Mount Hopkins, and you go through, as you describe in the book, right? You go through this period around 3 a.m., especially if you're, not an energetic young grad student anymore. You're kind of fading, and you're kind of, and then we got the email of, oh, there's a supernova. And so we have our own program for the night, but occasionally you'll get contacted by someone going, this thing's happening right now. Can you interrupt what you're doing and look at my thing for me, please? And so we were desperately trying, as the dawn started to approach, trying to get photometry, trying to get pictures in different color filters of the brightness of this new supernova to I think it was a gamma ray burst. In fact, it was a gamma ray burst. And we were this was the first time you were able to use a small telescope, the 48-inch on Mount Hopkins, to get early data on a gamma ray burst counterpart. And so it's like, you take this picture, and now you've just got like half an hour before it's daytime, and there are 100 stars in the file photo of this part of the sky, and now there are 101. And you have to find where the new one is.
Which one?
So that you can zero in on it and give it to the guy down the hall who's going to take the spectrum. And and it was really, I mean, as in any job, right? A lot of my job is very, boring meetings and things like that. But there was, you occasionally get these half hours where it's just like closing scene of a movie kind of excitement. That's awesome.
One of the folks I interviewed in the book described astronomy as the most exciting, boring job in the world. When everything is going well, you should be going, perfectly through your checklist, going, let's point the telescope here, and then let's point it here, and then here. And you quietly go through your list, the telescope's working, the weather's cooperating, and it can get very lulling. And the odds of everything working and everything going as expected are very low, whether it's a supernova going off or something breaking on the telescope or a computer problem. But it is a funny contrast between how quiet it could be and how very chaotic it sometimes can be. I'm also glad you mentioned gamma ray bursts, because I write about those in the book. These are these extra extreme versions of supernovae, of dying stars, that I actually studied in my PhD thesis. And I'm glad you mentioned nights being interrupted, because a thing people don't necessarily realize is astronomers don't just get to show up at a telescope and say, I'd like to point at that. We have to write proposals that are similar to how other scientists write grants. And we are given, a night on a telescope. And if you show up on the night of January 19th and you have a plan and it's cloudy or something's wrong, you can't just say, I'll stay tomorrow night, it'll be fine. Somebody else has been assigned that night and they're arriving with their program. So even when you're interrupted for something exciting like a supernova, there's this constant feeling of, this is my time, I only have 8 hours, possibly for years, I need to make the most of it. So it makes for an interesting tension in the middle of a night in the middle of nowhere.
Absolutely, and sometimes you get like 3 nights if you're lucky, and depending on the project. I remember one night in the 80s, I was out. I was sent from England, where I was a grad student, to Australia, and I in my 3-night run in Australia, I got like half a night of usable weather, you know. And so that's a long trip away. So that makes you think about remote observing, but you know, remote observing is not the same somehow. You do lose some understanding of the data that you're taking, I think. How do you feel about that shift from, so with remote observing, you're using you stay home and basically, you know, observe by Zoom essentially. And how do you feel about that?
So it was interesting writing the book and sort of outlining the Last Stargazers in 2019, because at the time remote observing was becoming more and more common. I still loved traveling to the telescope, and I had an experience similar to you that I also write about in the book, where I flew to Chile and sat there for 2 nights in this telescope that was cozy as a clam. It never opened because the weather was too bad to so much as crack the dome open, and it was a very long trip for nothing. But I still love actually being there and physically being at the telescope, seeing what the sky looks like, and being involved as the data comes in. But we had, in 2019, started to build the capability for me to sit here in my office in Seattle and use my laptop to run a telescope in New Mexico. There would be an operator, a person specially trained to run the telescope, that I was sending messages to, who I would say things like, can we focus the telescope? We're going to the next target. Is it still cloudy out? And there was a certain convenience about it because I could observe in my PJs, I could observe on the couch, but I also missed knowing what it was like at night. And I actually write near the end of The Last Stargazers about this really strange night where I had observed remotely on 2 different telescopes in the same night. And it was amazing for the science, but I remember thinking, oh, I bet the sky was beautiful. I'm in the middle of a city and I never saw the stars that I was observing. Of course, now during COVID, we have shifted to almost entirely remote observing. And I got the chance to observe remotely at that same mountain in Chile that I went to years ago, but over a computer. And we got great data, but I do miss the chance to actually be there. And you sometimes miss the chance to say, it's cloudy over there, it's clear over there, let's point to this. Like, there's a little bit of nimbleness that gets lost. On the other hand, it's very accessible. It's been a great tool for people who couldn't safely travel, but it's an interesting shift.
Yeah, I mean, I think you do lose some sense of how photometric really was it. You say, is there a sucker hole somewhere? Is there? Yeah.
We should explain. The joke is that sometimes you'll be looking at the clouds and this little hole opens in the clouds and you can see just a few stars and you see clear skies, and astronomers will famously go, oh, there's a hole, it's clearing up, and they run back into the telescope, and by the time you've got there, the hole's closed and there's nothing to see, but you have to hope. Yep.
Yeah. I once got scienced that way though. My amateur astronomer background came in handy for once, in that I saw Arcturus through the sucker hole, and I knew that my quasar that I wanted was in Boötes. And so I thought, okay, my object is in the sucker hole, I can go for it, and I got the data. So once in a whole, 40-year career, it actually came in handy to know the sky.
Another element of the book that I loved was the amount of nimbleness that people would display when they were observing in person, when it was cloudy except for right over your object. Or there was a great story I heard of when telescopes, which normally tip back and forth so they can be pointed, their telescope had broken and it was stuck pointing straight up. And a lot of astronomers would have given up and just gone, telescope's not working, time to go to bed. And this was the great Vera Rubin, the woman who discovered dark matter. She now has an amazing new survey telescope named after her. She was such a good observer that she was able to quickly do the math and say, well, what's going to be passing over our telescope? We can't move the telescope, but the sky is moving because the planet's slowly turning. And she just made an entire night of great science off of what does our telescope happen to be pointed at, which I don't think very many people could do. And there are so many versions of that, of telescopes breaking, weather not cooperating, cameras malfunctioning, or people frantically trying to fix something and people hurting themselves in the process in some cases. But there's a lot of sort of glued together with spit and scotch tape style observing that people managed to do.
Yeah, I think I was reading, I think it was a Charlie Stross novel, which described the criteria for getting a PhD as being stupidly persistent.
Yes.
I think that's a really accurate description of the sort of personality traits you need to be successful.
Oh yeah. I remember hearing stories told to me, and a couple of them are in the book, of people that would be observing, and observatories can actually be kind of dangerous places sometimes, and somebody had, tripped over something in the dome and injured a wrist or a knee or something like that, and they'd be getting taken away for medical attention and calling to their colleague like, point to the next target. And just like, I know I'm hurt, but we have to keep doing science. Yeah,
the show must go on is very much part of our DNA, I think, as a culture.
And that love for the science and that sort of like desperation almost to, we have to answer these questions about the universe is something that I really tried to get across, because it is objectively almost crazy. It seems almost silly to people that somebody would be that obsessed with, I need to answer this question about dust in a faraway galaxy. But when you poke at the science, you realize how important those questions are and how valuable they are to the people doing the work. So hopefully as you read, you start rooting for somebody to say, do point to that one more thing. It's very important.
Absolutely. Yeah. And of course, part of that as well is, it's like you've got your 2 nights, your 3 nights, and as the Earth goes around the sun, the stars only up in the middle of the night sky from that observatory for a few weeks a year. If you don't get it this time, it's another year, which maybe means another year on your PhD. So
yes,
you gotta get that data, right? And please
go ahead. I was going to say, I had a colleague make a really interesting point to me once that astronomers, by and large, do not believe in astrology and do not subscribe to the idea that the stars that were up or on the other side of the sun when we were born dictate something about our lives. But he did make the point that, funnily, astronomers know that there's no scientific basis for astrology, but our lives are dictated by the stars more than anybody else, because
exactly, like we are the one group of people who are affected by the stars. Yeah.
One cloudy night or one unusually timed supernova, and like you said, your PhD takes an extra year. I know people who had to delay weddings, who were not able to live near their families because of one night at a telescope that delayed their research, or people whose careers were made by being in the right place at the right time for discovery. So our lives do get impacted by the stars in these tiny little ways.
Oh, absolutely. Yeah. By the way, I see we're starting to get stuff in the Q&A. I'm going to propose that we wait till the Q&A session to answer them, but yes, keep those questions coming in. Your book opens with a trip to the Subaru Telescope, which coincidentally has gotten famous recently as starring in Don't Look Up.
Yes.
I was wondering, maybe think, you must have used a lot of different telescopes in your time. Do you have a favorite? How do you find the differences between them?
Oh, it's so hard to pick a favorite, but I did get excited at the beginning of Don't Look Up, seeing my familiar telescope that, much like that character, I used for my PhD thesis. I do love the telescopes that I get to go to. Like I mentioned, Las Campanas Observatory in Chile is one of my favorite observatories to visit. It's such an exquisitely beautiful place. It's got some of the darkest and most amazing skies in the world. As a PhD student at the University of Hawaii, I got to use some amazing telescopes at the summit of Mauna Kea Observatory. I think if I had to pick a most memorable telescope visit or sort of observing experience, it's another story that I share in the book when I talk about airborne astronomy. And a lot of people don't realize what airborne astronomy is, or even that we do it. But for the most part, when you picture a telescope, you picture a very large telescope sitting on the ground. And NASA actually right now has a telescope that they operate that is sitting in the back of a specially designed Boeing 747. And this plane is designed to fly into the stratosphere higher than normal passenger planes fly, and then open its back door to expose this telescope. And the telescope is specifically designed to detect a type of light that we can't really see from the ground, because that light is blocked by water vapor in our atmosphere. So astronomers are welcome to fly along with this telescope as it observes, and I got the chance to do this, take a couple attempts at it, and I tell these stories in the book. But I really never imagined when I was a little kid getting into astronomy that I was going to be flying on a telescope plane over sort of the southern hemisphere and seeing the southern lights out the window. And that was the most wild adventure thing that I've gotten to do at a telescope for my research.
That is pretty cool. Yes. No, I've never gotten to do that, so I'm a bit jealous. I think, there are these very different kinds of telescopes. There are also very different kinds of job in astronomy that you go into. And one distinction that you make is between the PhD astronomers and people like the telescope operators, which is a job that I think most people don't know exists.
Yeah, and which is too bad because it's a crucial job in astronomy. I, as an astronomer, have a PhD in literally astronomy, and my undergraduate degree is in physics. And I can tell you a lot about the physics of how stars work, about how they form, about how they die and make supernovae and release flashes of gamma rays and make black holes. I have learned about how telescopes work. I understand the optics and the principles of how they work. I absolutely could not fix one if it broke, or tell you anything about how to run one on a day-to-day basis. And for that, we have professionally trained telescope operators. We've had people in that job for years. I think they used to be referred to as night assistants. And in some cases, they would work specifically with particular astronomers, sort of assisting them on telescope operations for their projects. And now we have people who are specially trained to operate specific telescopes. So when I go to Las Campanas in Chile, I show up with a list of things that I want to observe, but I'm dependent on the telescope operators who are, for the most part, locals with engineering backgrounds who've been trained to operate these telescopes, explaining, I'd like to focus the telescope, we'd like to calibrate the telescope, we'd like to point here or there. Oh no, the telescope made a bad sound, is something wrong? And they are the experts that get to take care of all of this.
Right. And in general, what happens is on the business end of the telescope are the cameras. And my experience is, as an astronomer, you get to fiddle with the cameras. You can,
I can open the shutter.
Photographs in your case, and in fact, one of the scariest things for me was always refilling the camera dewar with liquid nitrogen. So you're going out there with like gloves on your hands, and all this like deadly liquid nitrogen is like flowing everywhere. And
because these cameras have to be kept so cold. Yeah, I remember at my very first observing run, one of my first jobs was to fill the dewar attached to the telescope instrument with liquid nitrogen. And at the observatory I was at, they led tours. And I remember looking down toward the little window at some point and seeing a group of like fourth graders watching me fill this with like smoke pouring out. And I felt like I looked very cool. But,
yeah, it definitely is one of the more, it goes to your point of like, it's not just sitting at a at a telescope. There are actually kind of sporty things that we do. And definitely driving up the mountain in the winter is one of those.
Yes. There's a whole set of tales in the book on how do we even get to these observatories, because you're typically flying an incredibly long way and then driving out into the middle of nowhere and then driving up a mountain road that may or may not be well maintained, while very jet lagged, and while trying to get onto a night schedule. There's never any street lights. You're often warned to turn off your headlights if it's dark, because even your headlights could cause problems with the observations. So there's a long list of astronomers who have had, thankfully mostly minor, car accidents getting up and down from these observatories.
Yeah, I remember the first time going out going up the Mount Hopkins Road and being told, oh yes, and this corner is called Toyota Canyon. For reasons that people can guess, right? And it's extreme. So it is. It can be sporty doing the actual in-person observing, even in radio telescopes too. You also have done a little bit of radio astronomy. You were writing in a book about that. So not only imitating the Don't Look Up folks, but imitating Jodie Foster in Contact, which is the other great astronomy movie.
Yes. Well, and radio astronomy puzzles a lot of people, because when you think radio, you think what you hear in your car. And you think, well, do you listen to space, or is space on AM or FM? How exactly does this work? And radio is just a different part of the electromagnetic spectrum. So the light that we see with our eyes has a very narrow and specific range of colors. Radio light you can think of as being much redder than what our eyes can see. But a radio telescope, which sort of looks like the satellite dishes that you have on the side of your house if you have satellite service, are specifically designed to detect that type of light. But that light is so different than the light we see with our eyes that there's a whole different type of physics that goes on. And the way that you operate those telescopes is almost a different discipline entirely. But we're studying a lot of the same things. They'll still study planets around other stars or distant galaxies or black holes at the centers of galaxies. But I remember learning the language and the jargon of how to suddenly shift into a different field of astronomy. And it, as a student, really opened my eyes up to, the universe is huge and the tools we use to study it are pretty huge too. There's a wide range of different skills that you need to learn to do a job like this.
Yeah. Also, my experience is, even though astronomy, right, you're on the top of a mountain, you're still, you're on a nice sort of firm platform. At prime focus in a radio telescope, sitting hundreds of feet above the dish, and things like that. That really taught me that perhaps it's a good thing I didn't get to be an astronaut, because I don't always deal with heights that well. So yeah, it
can be an adventure.
It's pretty fun to see these enormous pieces of engineering and have them, actually use them to learn something about the universe, about where we all came from. The other thing I think that I was thinking about, contrast between how people think about astronomy and what it's really like. And I think, there's some of them are like the solo brilliant person versus it being about people and about being a team sport.
Yes.
And so maybe you want to talk about your experience with that.
Oh yeah, this, like you said, this is another big difference, I think, throughout science in general, between how people might imagine research and how research actually happens. We love imagining a lone genius in a room going, aha, I figured something out. And in reality, I remember talking to people who were involved in, for example, this first picture of a black hole that got published in 2019. And that took fleets of astronomers working at observatories all over the planet that were combined to work in tandem. I talked to people that worked at the South Pole Telescope who even wintered over at the South Pole, or people who had to travel to all of these different locations in Hawaii, in Spain, in Chile, and retrofit telescopes with special equipment so that they could all be synchronized. They wound up making a telescope that was effectively the size of the planet Earth in order to take this amazingly sharp picture of a distant black hole. And the number of people involved in that, I think, would surprise a lot of folks who think, oh, one guy must have had this great idea and taken this picture of this black hole. The same goes for the discovery of gravitational waves, so these little tiny ripples in space-time that come from the collisions of enormous black holes. That was a decades-long effort with thousands of people on it. When they successfully discovered these little ripples for the first time, I think that research paper had, 3,000 authors?
Something like that, yeah.
On it, like a notable fraction of all the astronomers in the world. And keeping that in mind and making sure that people know, there's big teams that need to do this research, and assuming our field keeps getting the financial support it needs and the, equipment support and sort of the structural support it needs, there's a place for you if you are interested in working in this field. We need a lot of people doing a lot of things to make this research work.
And it varies, right? I mean, I think I started off as a theorist before becoming an observer and a data person. And so I've written single author papers and papers, with just, a couple other collaborators.
Yep. And
now I'm working with the Chandra Space Telescope with a huge cast of people. And one of the nice things about being in the team is that you don't have to be an expert on all of it.
Yes.
And my favorite size is about a group of about 5 people, where each person brings, something different to the table, and you can trust them to be an expert in that piece that you're not really so certain about. And that's a really fun kind of interaction sometimes.
There's a stereotype sometimes, and I know this is sometimes helped along by movies of popular scientists, or movies with, the good scientists and the evil scientists, that scientists will fight with each other or compete with each other. And it's not like that doesn't happen. I write about cases in the book where groups have wound up racing each other because we're all human and there's a temptation. Nobody wants to discover something second. So competition will sometimes come up, but for the most part, you have to do science collaboratively. If I want to use data from the Chandra Space Telescope, Chandra studies X-rays, and I've never worked with X-ray data. I would come to you, or I would come to other folks who are experts in this and say, hey, you already know a lot about this. Why don't we team up? We'll get a lot more science done together. And that happens so often throughout the field.
Absolutely. I think, you know, Katie Mack did a great illustration, I think, on Twitter once, where she talked about, you know, had a cartoon of like the person working in their office alone and going, this is not science. I had and the person having coffee with someone and talking about their stuff. That's science. That's doing science. Yeah. And I think that's, you know, as someone who I grew up, unlike you, I grew up in an academic family. All of my babysitters were physics graduate students.
That's amazing.
So I didn't realize there was another career option. So I was pretty familiar with the field, but yet it still surprised me how much people skills and human interactions are such a key part of the job, and not just math skills and you know, the sort of stereotype Greek philosopher thinking about idealizations.
Yeah, there's a interesting, I feel like this is a disservice that's sometimes done to science, because not that you and I aren't both fabulously nerdy, but there's sometimes this strange, I'm speaking for myself, but
no, absolutely, I own it.
But there's this strange stereotype sometimes that scientists can barely hold a conversation, or that we can't explain the research that we do to anybody but another scientist. And while that skill level varies from person to person, we have to be able to explain what we do to get research funding or to get access to telescopes. And we have to be able to work with each other, because no person, especially these days, there's no one individual who alone knows every different type of science to make some giant discovery. Like you said, occasionally you might write a single author paper. I've written those, or you write them with one or two other people, but you have to be able to work together. And you mentioned growing up with an academic family and physics babysitters, which is so great. And growing up, I had a family of folks who were not professional scientists, but I always tell people my parents were scientists in spirit and loved exploring the natural world, naturally knew how to think scientifically and ask questions, and they passed this on to my brother and I very much so. So I knew I loved that part of science. But I was also one of the only kids in my town that, you know, was reading books about the Apollo program instead of going to soccer practice. And I remember thinking, you know, am I ever going to have any friends? I know I want to be a scientist, but am I just going to be alone? Are you just kind of stuck as one of the weird people that enjoys this stuff? And what I remember was watching this amazing event that happened in 1994, which was when the Schumacher-Levy 9 comet hit Jupiter. And this was covered on the news because people were saying, you know, this comet is going to hit a planet. We've never gotten the chance to watch what happens when an event this drastic occurs. And we had a fairly new Hubble Space Telescope pointed to it. I remember watching the news coverage and seeing a group of people sitting around computers at what you and I know now as the headquarters in Baltimore. And they were watching the first images.
That's right, with Heidi Hammel, right?
Yes, with Heidi Hammel sitting in the middle. And I loved seeing a young woman in the middle of that too, but I don't remember noticing that she was a woman so much as I remember noticing that she had big glasses and the sort of like no-nonsense kind of geeky clothes that I wore, and everybody around her was dressed the same way, and they were cheering and grinning at each other and like shouting because they were so excited. And I remember watching that and going, they're having a lot of fun. I think I want to do this job because I want to be hanging out with them.
Right, exactly. And it is such a privilege to be able to do this job, I have to say. And not just, I mean, I got into astronomy because my mind was blown by thinking about, you know, the amazing nature of space. But I stayed because of the people who are, you know, like you say, not that there aren't, you know, problematic individuals, but but by and large, I love astronomers, and they're fun to be around, and so that's, I think, why I've, you know, stuck with it, and I'm really happy to be in the field. And I think, you know, it's really nice to read about how the people who inspired you like that moment, but also like I noticed your visit to Wheaton, which Wheaton College is a small college in Massachusetts that I've given guest talks at, and they had this amazing array of telescopes on the roof that I think the person you met might have been Tim Barker.
I was wondering if I could find out who this was, but
he's retired now, I think, but
he would have been the first professional astronomer I ever met. Yeah.
Right. And Tim was great. And he had managed to persuade Wheaton to put this enormous array of telescopes on the roof, and they could they could control them remotely from the desks in the classroom and things like that. And something I just wasn't expecting to see at a small college like that. And so there are so many people who do such great work in bringing the work that research astronomers do to the public, and then inspiring the next generation like you, and that's so important. And then you did. I have to go there because this is sort of so much of my life is you did an undergraduate summer program like the one that I helped run here at the Harvard-Smithsonian.
Yes.
And they popped you on a project doing red supergiants,
which I now still study to this day.
Exactly. And it's been really interesting to me watching my many students over the years, which of them have like just gone totally different directions, and which of them have like 20, 30 years later still doing the project that we gave them as an RU student, like, oh, I'm sorry, I ruined your life, but
a program like that was amazing to me as a college student, because I had been a kid interested in science. I applied to colleges knowing that I wanted to be an astronomer or that I wanted to do physics or something along these lines, and I wound up at MIT, which was wonderful, but wow, that was very different than where I went to high school. And I had a wonderful, wonderful time there. I met lifelong friends there. I met my husband there. But I remember finishing my sophomore year going, I'm hanging in there. I passed quantum physics. I passed thermodynamics, but I'm not sure, am I really going to be cut out for this? Is this really the world for me? And that was the summer that I got to do this research experience for undergraduates program. And I got to do hands-on research for the first time. And that reminded me of high school science fair projects. That gave me a chance to grab all the thermo and quantum and physics of light that I had gotten okay grades in and actually apply it to something. And it was such a magic moment for me going, oh, this is what this career is going to be like. And these are the people who I'm going to be working with. That was my first time ever going to a telescope and observing at one. And the welcome that other astronomers gave me to the field of sitting in the cafeteria on that first night of my first time at a telescope, telling me these wacky stories of the field. That was what wound up sparking the idea for this whole book, that sort of storytelling is how you can welcome people and show people what our jobs are like, who astronomers are and what the people are like, and really give that window into here's what this work is actually going to be that you might not otherwise get.
That's so interesting. Yeah, let's talk about how to make a culture that is a welcoming culture and not a gatekeeping one.
Exactly. Yeah.
And I think we do that more or less well in
something we're still working on and still getting better at, which is wonderful to see in the field. Yeah.
Absolutely. We're making, I would say, slow progress, but progress. And so that's always interesting to me how you how these initial experiences can mold a career. And I want to make I just want to mention that to any undergrads or high school students that are listening, that it's research is so different from college classwork.
Oh yes.
And get a research experience as early as you can, because that is what the profession is, and you need to experience it. And it's what we look for in applicants is, have you tried to do research? And so that's a key thing.
It's also another chance to get like this sort of like behind the scenes look and this hands-on glimpse at like, here's what science is actually going to be like. And I did this summer of research at Northern Arizona University in Flagstaff, Arizona. We observed down at Kitt Peak in Southern Arizona. This is one of the stories in the early part of the book. I loved it. I couldn't give up the research project. Clearly, I'm still working on an offshoot of it. I had students that I went there with who had a wonderful summer. I had a great time with them, who said, this isn't for me. This is cool. I'm glad I tried it, but I want to do something else. I like teaching more. I had somebody I did that same REU with wind up going to law school. And it was a great chance for them to say, I'm really glad I tried it. I know what I like about this. I know what I don't like, and I'm going to go in this other direction. So it's such a wonderful chance to get a glimpse of what your career is going to be like. And yeah, for any undergraduates watching, any chance to do research is so valuable.
And it's not right for everybody. That's right. And it's not. And as an RU director, I would say I don't see it as a failure when someone doesn't end up going into astronomy. I'm still in touch with students from 20 years ago who went a totally different direction and went into some other field entirely. And they still, by and large, they still feel like it was a really good experience for them, even though they decided not to carry on in that direction. And so I feel like that was good. Better to discover now that you don't want to spend the next 6 years doing astronomy grad school, right?
Exactly.
But for those of us who do love it, it's that first experience is always great. I remember my internship at the Royal Greenwich Observatory in a haunted castle in Sussex.
It doesn't get better than that.
I'll tell you. So we don't have time now, alas, but I'll tell you sometime.
And by the way, for people watching, I know someone asked, what isn't in the book, and so many stories like that. My interviews with people, I have hours and hours of recordings where I just said to people, tell me your most memorable stories of observing, of working at a telescope. Tell me the craziest story you've heard from someone else. And I had to curate these stories so heavily to make sure that the book didn't just become an anecdote collection. It sort of follows the arc of, how astronomy has evolved. It follows how my own career progressed. And I could have tripled it in length and just told every crazy story of, for example, the time an animal wreaked havoc at an observatory, when swarms of ladybugs would clog a telescope's dome to the point where it couldn't open. Or, the story of the bear getting into the observatory did make it into the book, but so many people have wild stories of these incredible places they went to, the wacky adventures that they had. And I really had to pick the highlights reel for the book, but astronomers can sit at dinner after a conference for hours passing these around. And that's some of what I wanted to capture.
Yeah, and on that note, because we're running on in time, although there's so many more things I want to ask you about. I want to ask about how we've evolved from photographic plates to digital data, how we've evolved in all these different ways. I want to ask you about Thorne-Zitko objects. I used to share an office briefly with Anna Zitko, so back in the day in the 80s. But maybe we've got a bunch of questions, so maybe we should we should move on to the question session. So I'm going to look at the Q&As. Well, actually, let me first look at the chat, even though that's where we're.
We've had some very nice comments in the chat.
We've got some very nice comments in the chat, and it's great that people remember the astronomers they first met and how they were inspired. John, yes, I do know Amy Mossman very well at Harvard-Smithsonian, so I'll say hi to her next time I see her. So moving back on to the Q&A. So our first question is about Catherine Zucker's new paper. Catherine's another of my former RE students, and she has a fantastic paper that I really want to grill her about in person on the local bubble. And so the question is, Emily, could you tell us more about? This is not a political bubble. This is an actual physical bubble.
A literal actual space bubble.
Yeah. What space bubble? Tell us about the space bubble we live in.
So I'm not an expert on this particular paper, but what this research was tracking is basically how our sun's neighborhood has evolved, and tracking this sort of bubble that is expanding around our sun and sort of nearby star clusters that's propelled by supernovae. So by massive stars whose cores collapse, they undergo this amazing rebound explosion. And in aggregate, when you think of lots of explosions going off, or you think of so many things like this happening in the vacuum of space, you are effectively, as Catherine discovered, blowing a sort of bubble around our sun and its neighbors and clusters of stars nearby. And these bubbles are fascinating because they may be prompted by stellar death, by an exploding supernova, but they can also kick off stellar life and the formation of new stars, because as the edge of that bubble expands, it basically acts like a shockwave. It'll disrupt things like nearby clouds that can start to get a little squished and condense to form new nuggets of stars that then turn into new nurseries of stars and generations of stars. And the paper is this wonderful glimpse at that cycle and how it's working right around us in our local stellar neighborhood, and how we understand this whole cycle of stellar life. So people don't necessarily realize that stars are born and evolve and age and then die, and all of that is encapsulated right in our solar neighborhood and right by what she wound up observing.
Right, and I think it's this idea of how the supernova triggered star formation, tongue twister, this time of the evening, that's been around for a long time, and I think this is just a really nice demonstration of, yep, that theory is right, and here it is happening right here, and so I think this is a really nice paper. So Nia asks, if you're able to talk about it, what projects are you working on now?
So this is an excellent excuse to actually talk about Thorne-Jitgov objects, which you'd mentioned asking anyway. So this is one of my favorite areas of research to work in right now. And this is actually, where these came from is actually a story that I tell in The Last Stargazers, because my colleagues and I discovered what we think is a new type of star. So a normal star is able to sustain this very delicate balancing act between sort of the inward squish of its own gravity and the outward energy generated by, in most cases, nuclear fusion. Stars basically operate little nuclear reactors in their core. A star like our sun is fusing hydrogen into helium. Stars that are later on in their lifetime, so a great example is Betelgeuse, the red supergiant in the shoulder of the constellation Orion. Betelgeuse is fusing helium into carbon, and very massive stars can fuse heavier and heavier things. And this is how most stars are able to sort of stay stable. Thorne-Jitgov objects for cores don't have these fusion reactors. They have these tiny leftover husks of dead massive stars called neutron stars. And those stars are actually supported by principles of quantum physics. And for a long time, Kip Thorne and Anna Zhitkov had predicted that stars like this should be able to work. And in an infinite universe, if something should exist, that means it can exist, it probably should exist. And they had been predicted as this idea, but nobody had ever seen stars like this. And I write in the book about how my colleagues and I found what we think is the best candidate yet, our most likely chance of having found a Thorne-Jitgov object and having found a star that actually works this way. So I'm now continuing to work on this with my research students at the University of Washington. I have a first-year graduate student working with me on analyzing the chemistry of these stars' atmospheres, because that's the biggest hint we can get as to what's going on inside these stars. We're studying the binary systems that we think form stars like this. We think that these stars are made when two stars that are in a binary manage to merge. I'm proposing for funding and projects for next year where I can go work with experts on binary evolution and experts in simulating how these stars work to see if we can predict where these stars might come from, how many of them there should be, and where we can look for more. Because so far we found one. We'd really like to find more of them. The observing that I got to do recently was studying these sorts of very cool massive stars and studying the chemistry of their atmospheres in the hopes of maybe finding more. So it's been a really fun project to keep working on. I have a soft spot for weird stars, so that's one of my big active projects right now.
I have to tell you, I was so excited when you found it, having known and having heard about these things, and they're kind of ridiculous objects, right? And I think of them as the astronomical equivalent of like these parasites that take over an animal's brain and make them do things. Hidden inside another thing.
They outwardly look like normal stars. They would actually look just like Betelgeuse if you could see one in the night sky, but they've got this bizarre quantum physics going on inside instead of the fusion that we used to think stars needed. So, yeah.
Right, exactly. And I think, was it Powell, one of the early quantum people, who said that anything that in physics, anything that's not forbidden is compulsory.
Is mandatory. Yeah, or compulsory. Yep. That's exactly the principle that drove why we thought we should look for these.
So great piece of science on your part to go and follow that up, and good luck on your hunt for more of these there.
Thank you.
And that's the thing, right, is that in astronomy, first it's really hard to find the first one.
Yeah.
And it's still pretty hard to find the second one. And then they start coming in by the dozens, right? That's what we found with exoplanets. Now there's thousands of them.
Yeah, with gravitational waves, with fast radio bursts. There's so many fields where I always think of it as one object as an oddity, two is now a class. You've now got a class of new objects.
Two is now two subclassifications, but that's a whole other story. Right?
That's a separate problem. And then, we wind up with thousands of them, and we wind up with catalogs of them, but it has to start with the one. And it's kind of enjoyable to be working on these stars from the very beginning. And hopefully we get to the point where we have a heap of them and catalogs of Thorne-Jitgov objects.
Yeah, absolutely. So there's a question from Colleen who asks, will the images from James Webb, you wanted to get to James Webb, here it is, will they be an open source for all astronomers to work with, and are you going to be involved with it?
I am very much looking forward to being involved with James Webb. So the way that telescopes like the Hubble historically and James Webb going forward work is people will propose for time on these telescopes, kind of like how we propose for time on the ground-based telescopes that I talk about, and will be granted a certain number of orbits in Hubble's case, or a certain number of hours in James Webb's case, to point at a galaxy or star or nebula that we're interested in studying. Once our observations are taken, they're kept proprietary for a certain amount of time. So a team might take a picture and then they have that picture for 6 months and it's just theirs, and they can get a little bit of a head start on their research. And then that data is made public for everyone. More and more teams are actually starting to waive that proprietary time where the data is only theirs and saying, take this data and make it public immediately. And once it's public, anybody in astronomy or anybody that can access the archive is able to download it and work with it. And this data is often very complicated and can be impenetrable if you haven't had practice working with it. But we're very quickly, once James Webb is up and running, going to have these beautiful archives of Webb observations. And I can't wait to use it to study, honestly, Thorne-Jitgov objects or cold stars, or these stars that are going to emit a lot of infrared light, which is the type of light that James Webb studies. So I'm looking forward to kind of seeing what James Webb's universe looks like and what data we'll be getting from it.
Right. I think the open archives we have in astronomy are great. I want to sort of make one little rant about how I see science, which is that when I do a research project, right, it maybe takes me, when I get the data, so I had like 2 nights on the telescope and then a month getting to the answer, analyzing the data, and then 6 months convincing myself that I haven't screwed up. And that is the part that's really science, right? Is checking all the ways that you might have got the wrong answer. And that's the part I think that distinguishes someone with training from, and so it's very easy to get the wrong answer if you're not sufficiently paranoid. And especially if it's an exciting answer. If it's an exciting answer like, oh, I found a Thorne-Jitgov object, right? Then 9 times out of 10, a week later you go, no, I didn't, I was wrong. And occasionally it's something awesome and you're right, like in this case, but you have to be really, really skeptical of, you have to be your own worst critic, right?
I remember us spending weeks, I always think of it as a good scientist is constantly trying to prove themselves wrong. And I think people see scientists in the news, or they'll see a depiction where scientists are pictured as constantly trying to prove others wrong. I think if you're doing it right, you're poking at your own data and your own results going, what did I mess up? How is this wrong? What is somebody else going to catch? What did I do incorrectly? What's the simplest explanation is usually not, I found a totally new type of star. It's usually, I made a mistake. So I remember us spending a long time trying to figure out how we could have messed up our Thorne-Jitgov object. And getting the data is step one. Analyzing the data is its own process. And then making sure you did it right is the most important step.
So I think that, we have all of this data available publicly. The software is by and large all open source and free. And most of it runs on Macs, usually not Windows. I use Linux, but and so anyone in the world can go and get this data, but it's you do need a certain level of training to get the right answer out of the data. That's the only caveat I would say. Moving on with the questions. There's a question about so Roger asks, how is the LEO satellites like Starlink and OneWeb gonna impact astronomy?
Yeah, so this is low Earth orbit satellites for folks who don't know, and I am lucky to be speaking with an expert on how these are going to impact astronomy. So I'll give my short answer first, and then I'd love to hear you say a little more about this. I've had a lot of people ask me this. I've had people ask me whether the title, The Last Stargazers, is actually in reference to increasing satellite pollution and the idea that our night sky is getting more and more crisscrossed by satellites. I know that a lot of colleagues and I are concerned about this, and we would like to see this carefully dealt with and regulated, because I think what mostly alarmed people is that companies right now can launch satellites with approval from the FCC, not approval from an international body focused on protecting the night sky. There are a lot of people working on that, though, like you, and people who are focusing on how we can enjoy the technological advances of satellites without sacrificing a night sky that we won't get back if we keep throwing things into low Earth orbit. So I'm acquainted with the citizen observer who has had colleagues say they'll describe it as getting Starlinked, because they'll be in the middle of observing and this fleet of satellites will pass over their telescope and it looks like a cat clawed the image. There's just these like white lines that are destroying all data that's behind them. It's not something you can just remove with the computer and get back. So I'd love to hear you say more on this as an expert in how this is impacting the field and what we're doing about it.
Yeah, I mean, one of the problems, right, is we're not just taking pretty pictures. We're trying to measure brightnesses of things to like 1%, and a little bleed off from the satellite trails can affect that, can limit what you can do. And so it's not just, oh, fix it in Photoshop. That's not what we're doing here. So I do think that, you know, we've been working with SpaceX. We've got some improvements to what's been going on. I think in the near term, it's going to be an insane annoyance and be more work for astronomers to get science out of their data, but it's not going to be disastrous in the short term. But in the longer term, it's clear that the technology is there to put up these bright low orbit satellites that could make many projects, particularly things like near Earth object source searches and things like that, much more difficult to do. So we're not screwed yet, but we do have to, I think we have to establish that near Earth orbit is an environment, that the night sky is an environment in the common heritage of humanity, and that we have to protect that. And that doesn't mean banning these systems, but it means having some kind of international regulations to constrain these systems so that they can't just arbitrarily be, you know, I mean, people have occasionally talked about, you know, advertising slogans in the sky and things like that, right? There's a direction that we just don't want to go. So it's a challenge, and a lot of us are working hard on it. There's a new IAU Center for Protection of the quiet, dark and quiet skies that's coming along soon, and so there's a lot of work going on this. Kathy says she worked at JPL for 36 years, respect, and wonders if either of us have used data from our interplanetary spacecraft. I have some. Have you used anything?
I have not, just by the nature of the type of research that I do, but I absolutely love following the work that people do with these. It's incredible to me that we have a planet in our solar system populated only by robots.
Absolutely. It's amazing. The one thing I've done is I've used Pioneer 10, when it was out beyond the asteroid belt, used its photometer to measure the brightness of the background light. Right, out beyond the asteroid belt, there's a zodiacal light. Right, the sky is darker, and so if you're looking for the light from distant galaxies just after the Big Bang, back in the 1980s when I was doing my thesis, that was actually one of the best constraints. And so Pioneer and Voyager did some nice real cosmology stuff in addition to flying past the planets and visiting the pretty distant planets. So that's the one data set that I've really used from that. The other thing, of course, is the gamma ray burst network, where having gamma ray detectors piggybacked on some of these deep space probes, you can triangulate and see where the gamma ray burst is coming from. So that's been very useful.
Yeah, no, the interplanetary capabilities that JPL has and the amazing sort of engineering feats that they've pulled off have been amazing for astronomy. And the fact that I happen to work in a different field that hasn't used them, I'm still just like fascinated by watching the things that JPL can do. So I know we're almost out of time. Do you think we have time for one more?
I mean, I'll defer to the Powell's folks for that.
Yeah, go ahead and do one more.
All right. Well, I think the right one to do is Tove's question, which is, what one thing didn't make it into the book that you most wish you could have included?
Oh, I'm gonna cheat and answer Tove's question and Laurie's question because the two answers are related. When I was writing the book, I knew that I had to limit its scope in some way because I had so many wonderful questions from colleagues. I knew I would be writing about literally an entire planet's worth of telescopes, and I realized I couldn't write about telescopes on the ground and telescopes in space. I'd have to pick one, and hopefully the stories of telescopes in space will be its own book. And I also realized I have to write about professional astronomers, people who do this. This is our day job, no pun intended. We do astronomy full time, and it meant leaving out the contributions of amateur astronomers. And amateur astronomers will have very different career experiences, very different lives. So it helped to focus the book on this behind the scenes glimpse of professional astronomy. But I was sad that I couldn't include how much amateur astronomers contribute to the field. And Laurie's question was asking on how amateur astronomers contribute to science. And when we describe amateur astronomy, it covers a wonderfully wide umbrella. It covers somebody standing in their backyard and just enjoying the night sky and maybe looking at a map on their phone. It covers people with binoculars, and it goes all the way up to people with amazing backyard telescope setups or remotely operated telescope setups, professional cameras, spectrographic instruments where they can measure the chemistry of whatever they're looking at. Like it's a broad brush. I have research students. I had a conversation on Zoom with a research student today who was using entirely amateur astronomy data to study how the brightness of stars varies with time. There's databases of amateur data that professional astronomers use, and we will team up with these folks very closely. So the contributions from amateur astronomers are amazing. And in the interest of focusing the book on the life of professional astronomers, I had to leave those contributions out, but I hope somebody writes that book about the world of amateur astronomy research and how there's this wonderful, enthusiastic sort of community that works alongside professional astronomy and makes really incredible contributions with backyard or a really wide variety of setups.
Absolutely. And I want to give a shout out to the AAVSO, the American Association of Variable Star Observers, which is like probably the main amateur astronomy group in this country. AAVSO.org if you want to get involved.
Exactly. That's the data that my student is using. Yeah.
Yeah. And you know, I think every 10 years or so I hear, well, with the new telescopes coming online professionally, the amateurs will just be out of it. They won't be able to contribute anything useful. And every time they find a way they find a niche which isn't being addressed. So yeah, Rubin and other things are going to make, you know, certain kinds of amateur astronomy, you know, perhaps not so useful because they're just going to look at the whole sky all the time, whatever. But I think that amateurs will still find ways to contribute, and it's just been, I think culturally, I think it's really important that professional astronomers and amateur astronomers have this long-standing mutual respect and collaboration that, for example, isn't present in I don't know, professional amateur solid state physicists or something like that, right?
That's why I think it's an interesting story. The world of citizen science is fascinating, and I remember, you know, doing citizen science where you could try and sequence a genome using the cycles on your computer, but I can't think of another field where there is such a, I mean, I imagine fields like geology. There's a wonderful amateur birding community that I know will contribute to ornithology research. But amateur astronomy is this very interesting niche that has a nice close relationship with the professional community. And I think it would make for a great story for another book.
Yeah. So exactly. I think we've identified at least 3 or 4 more books that you need to write.
Right, I need to get on that.
So, but don't let that stop you doing more of this awesome research as well, because that would, we want that too. So
I'm enjoying multitasking.
Yes, exactly. Good that you're so productive. But in the meantime, please buy Emily's current book, which is I really enjoyed reading, and I think you will too.
Thank you so much, Jonathan, and thank you, Emily. Such a fascinating conversation. I just put the link in for Emily's book in the chat, so you can click on that and get that. And also, this is what the book looks like, by the way.
Yep.
And also in the chat, I'm going to put a link to our YouTube channel. So if you want to check this out tomorrow, or I know a couple of people asked in the chat if they're going to be able to see this again, so you can watch it on our YouTube channel. We'll probably post there sometime tomorrow. And yeah, thanks again for everyone for joining us tonight. Thanks, Emily. Thanks, Jonathan. Hope to see you in person in the store sometime in the near future. And everyone at home, have a great night, and we'll see you next time.
Thank you, everyone.
Thank you, everyone. Bye-bye.